I'm Andreas Hamberger, and this is the Hamberger Report, where I cover AI governance, enterprise architecture, and the technology decisions that actually matter to the people who have to make them. If you find this useful, subscribe and hit the like button. It helps more professionals find the channel. Now let's get into it. "16 minutes. That is the median time for an attacker to compromise an enterprise AI system, according to Zscaler's 2026 AI Security Report. 16 minutes from initial contact to full system access. Your security operations center, analysts cannot even finish their coffee in that window, let alone detect, triage, and contain a sophisticated threat. I'm Andreas Hamberger. This is the Hamberger Report, where I cover enterprise architecture in the age of AI agents. New Zealand loses an estimated $1.6 billion annually to cyber incidents. The NCSC's 2025 Cyber Threat Report documents $26.9 million in direct financial losses reported to CERT-NZ, but this figure captures only what organizations choose to disclose. The true economic impact, when consumer losses and unreported incidents are included, runs nearly 60 times higher. Here is the architectural problem underneath those numbers. We have built enterprise systems that operate at machine speed, while defending them with human speed processes. The mismatch was tolerable when attackers were also human, constrained by the same cognitive limits as defenders. That constraint no longer holds. Threat actors now deploy autonomous systems that probe, adapt, exploit, and persist faster than any human team can respond. The attackers have upgraded. Our defenses have not. This is not a technology problem. This is an architecture problem. And architecture can be fixed. For 3 decades, enterprise security operated on a simple premise: build walls, guard the gates, and trust everything inside. The castle and moat model worked when organizations had clear boundaries. Employees sat in offices, data lived in data centers, applications ran on servers you could physically touch. That world ended years ago. Many security architectures pretend otherwise. Cloud computing dissolved the data center boundary. Remote work dissolved the office boundary. Software as a service dissolved the application boundary. Each dissolution demanded adaptation, and organizations responded with patches, VPNs, cloud access security brokers, mobile device management, endpoint detection and response. Patches upon patches, each adding complexity while preserving the fiction of a defensible perimeter. Agentic AI represents the final dissolution. When your AI assistant browses external websites, processes documents from unknown sources, and communicates with external APIs, where exactly is your perimeter? The agent operates simultaneously inside and outside your trust boundary. It consumes content from the public internet while holding credentials to your most sensitive systems. The castle and moat model cannot accommodate an entity that is simultaneously a drawbridge and a siege engine. Zero trust architecture emerged precisely because the perimeter model failed. The core principle is deceptively simple: never trust, always verify. Every access request, regardless of source, must be authenticated and authorized before proceeding. No implicit trust based on network location. No assumption that internal traffic is safe. But zero trust for agentic AI requires something more than zero trust for human users. These systems do not just request access. They reason, plan, act, and adapt autonomously. They make decisions about what data to retrieve, what actions to take, and what external services to contact. Verifying the agent's identity is necessary, but insufficient. We must also verify the agent's intent, constrain its reasoning, and audit its decisions. This is the gap that current frameworks fail to address. Consider what the threat landscape looks like from the attacker's perspective. They see organizations deploying AI assistants with access to sensitive data repositories, customer records, and internal communications. They see these assistants processing inputs from external sources, emails, web content, shared documents, API responses, and they see agents capable of taking actions, sending messages, executing code, making API calls to other systems. Closures embeds probably the decisions. Researchers call the lethal trifecta. When an agent possesses sensitive data access, exposure to untrusted content, and external communication capability simultaneously, it becomes a direct pathway for data exfiltration. The attacker does not need to breach your network perimeter. They need only to craft a prompt hidden on a web page your AI assistant will read. In September 2025, a state-sponsored group weaponized a coding assistant to infiltrate 30 global targets. The attack succeeded not because of technical brilliance, but because the target organizations had deployed AI without understanding its security implications. This was documented by Wiz Research in one of the most significant security disclosures of the year. Gartner predicts that by 2028, 50% of organizations will adopt zero-trust data governance, specifically to handle the influx of unverified AI-generated data. This matters because when an AI agent generates a report or produces an analysis, how do you know the output is accurate? How do you know the agent was not manipulated by malicious content embedded in its inputs? Zero-trust data governance applies the never trust, always verify principle to data itself. Every piece of AI-generated content must carry provenance. Which agent produced it? What inputs it consumed? What model version it ran? For New Zealand organizations, this becomes legally relevant when Privacy Act Information Privacy Principle 3A takes effect in May 2026. An AI agent that ingests data from external sources is collecting data from third parties. Tracking data provenance is no longer optional. The shift required of enterprise architects is not incremental. It represents a fundamental reconceptualization of what security architecture must accomplish. Traditional security asks, is this user allowed on the network? Is this device compliant? Is this application approved? Zero Trust for Agentic AI must ask a different question entirely. Is this specific action by this specific agent on this specific data at this specific moment consistent with our policies and the agent's declared purpose? The granularity matters. An AI assistant authorized to summarize emails should not be able to forward those emails externally. An agent permitted to query a database for aggregate statistics should not be able to extract individual records. A coding assistant allowed to read source code should not be able to exfiltrate that code to an external repository. These distinctions cannot be enforced at the network level. They require policy enforcement at the transaction level, examining each action the agent attempts and evaluating against fine-grained rules. This is where the concept of the Logic Firewall becomes essential. A defensive layer that operates not on packets or protocols, but on reasoning and intent. The architecture must understand not just who is acting, but what they are doing and why. The Reserve Bank of New Zealand's February 2026 analysis found that 30% of New Zealand workers face high exposure to both AI and robotics simultaneously. Less than 5% face low exposure to either. The clock is not theoretical. It is ticking for nearly a third of the workforce. Forrester predicts that by 2026, an agentic workflow will autonomously prevent a major system outage, validating investment in self-healing infrastructure. The implication is direct. If we need agentic systems to prevent outages because humans cannot respond quickly enough, we need agentic systems to defend against attacks for exactly the same reason. The machine-speed conflict is not a future threat. It is the present reality. Every organization deploying AI without appropriate security architecture is accepting risks they likely do not understand and certainly cannot quantify. The attackers have made their choice. The only remaining question is whether your architecture is ready to match them. If you are an architect or CIO figuring out what agentic AI means for your practice, subscribe to the Hamberger Report for daily insights. And if you want structured TOGAF training adapted for the Agentic Age, the link to my practitioner course is in the description. That is the Hamberger Report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.